Welcome to video lecture series of Electric Vehicle Architecture course. Today we are going to talking about hybrid electric vehicles or HEVs, machines that combine two different power sources in one drivetrain, such as an internal combustion engine or ICE and one or more electric motors. Based on this, hybrid electric vehicle is a vehicle which may run with gasoline or with electric motors. The motor delivers full torque with instant current flow and exactly hybrid feel, so responsive when pulling away from a stop. A hybrid vehicle is really a system for handling the button back and forth between these two IC engine and electric motors. What is an HEV? Formally, a HEV uses two or more power sources to propel the vehicle, an internal combustion engine and one or more electric motors working together or independently depending on the driving conditions. The goal is to improve performance, improve efficiency, and reduce emissions relative to a conventional IC engine vehicle only. Here, we use working together or independently. That means they work together or separately. The flexibility of the whole design is the nature beyond it. That means the system doesn't force both the power sources to run all the time. It selects whichever combination is most efficient for the current, present load and speed category. Let us break down the key features that fall out in this dual power architecture. First, dual power sources that combines the IC engine and electric motor for efficient power delivery under different conditions. Secondly, the energy efficiency. HEVs recover energy during braking through regenerative braking and reduce overall fuel consumption. This energy that a conventional car simply throws away as a heat in the brake pads. Third, it has lower emissions. Fewer pollutions, smaller carbon footprints are there because the engine doesn't run constantly and it isn't working at inefficient partial roads. Next, we have better performance that gives that electric motors deliver instant torque, which improves acceleration compared to relying on the engine alone. And the major quiet thing is it has very quiet operation. That vehicle can run in electric only mode at low speeds, which is almost silent. That is why hybrids are nearly silent, pulling out in a parking spot. How the power train flow and how it works. The actual energy flow because there is two energy sources feeding into the system. Fuel goes into internal combustion engine and battery pack stores and provide electric energy to the electric motor. Both the engine and motor fed into a power control unit. In real time, it decides how much torque required and comes from which source. The output goes through the transmission and finally into the wheels. There is a feedback loop, that is, the electric motor and battery pack talk to each other in both directions. The battery power the motor, but the motor can also act as a generator and send the energy back to recharge the battery. That we call it as regenerative braking. So, three types of connections to be straight with actually drive the vehicle, store and provide energy and control the power as shown in the diagram. The control signal gives what the system has to do and what to do and when to do. And there are three different architectures based on the connections. They are very classic: series HEV, parallel HEV, and series parallel HEV. Let us see in detail with a glimpse. Series HEV, the engine never touches the wheels directly. Instead, the engine drives a generator, the generator produces electricity, and only the electric motor drives the wheel. The engine's whole job is to power the plant on wheels. It's decoupled from the drivetrain entirely. And regarding parallel HEV, both the engine and electric motor can drive the wheels either together or independently. There's a direct mechanical path from engine to wheels in parallel with motor's own path. So it is parallel HEV. In series parallel HEV, this combines both approaches. The engine can drive a generator like a series setup, and the engine motor also drive the wheels directly like the parallel setup. It's more complex, but the control system pick whichever mode is most efficient for that moment. That means it can give maximum efficiency and performance, and the cost of complexity is increases due to the mechanical design. So from this part, series decouples the engine from the wheels completely. Parallel keeps a mechanical link, and series parallel gives both the options of series and parallel operations, and depends on the controller's choice. Now let us see the operating modes. There are 4 modes that vehicle can operate: in EV mode, hybrid mode, engine mode, and regenerative braking mode. In EV mode, only electric motors are used, and they normally used for light loads and low speed with silent running. In hybrid mode, engine and motor work together, typically during normal cruising or moderate acceleration. When we go for high speed or high load, engine mode is activated. They use combustion engine with more efficient than the battery can give. And in the regenerative braking mode, there the driving mode is not happen, but the recovery mode comes. The kinetic energy from the brakes gets converted back into electricity and stored in the battery instead of dissipating as heat. So EV is a sprinter running solo, engine mode is the marathon running solo, hybrid mode is them running side by side, and regenerative braking is like sprinter banking energy for next leg instead of wasting it. That's an analogy. So regarding the advantages and application, what is the complexity? What are the factors that need to be considered? Improved fuel economy, reduced emissions, lower running, high reliability, performance, and smaller environment footprint. So we'll find different architectures for different applications like passenger cars, SUVs, buses, and commercial vehicles. So HEV act as a bridge technology between conventional combustion vehicle and fully electric vehicles. They support energy security, reduce dependence on fossil fuels, and contribute to more sustainable transportation future without requiring the charging infrastructure that a pure EV depend on. So let us choose an analogy. A hybrid vehicle is a control system managing two runners with two opposite strengths, a steady, efficient, and an explosive instant torque generation. Deciding moment should carry the load and even recovering the energy whenever it is required and not to be wasted. So, hybrid electric technology gives a quite improved transportation for the future. Thank you.